Okay guys, so once again I made the video and it deleted. Yay, it was over 20 minutes. So 12.4 shape of data distributions, page 891. I'm going to try and keep my cool and do this like normal, but yeah, I'm frustrated. So alright. Looking at the vocabulary startup, we're going to talk about distribution and some key words that we're going to be using throughout this whole section. It says the distribution of a set of data shows the arrangement of data values. The words below show some of the ways the distribution of data can be described. So match the words below to their definitions. So go ahead and pause the video now and match up. Some of them might be easier than others. Alright, so the first one that I had no problem figuring out was gap. The numbers that have no data value, those are a gap. We don't have any data value for it, so there's nothing there. Symmetry is where the left side of the distribution looks like the right side. That's pretty obvious because symmetry means same. So if the left side is the same as the right side, that's same, symmetry. Cluster is where the data that are grouped closely together, obviously cluster, grouped closely together. I think that's pretty obvious. The one that I wasn't really sure about, maybe you're a little confused on, is the peak, and we'll see that more clearly in just a little bit. But peak is the most frequently occurring values or mode. Just remember that if you can find all the other ones, the one that's left over will match up, right? So peak goes with that one. So the real world link says the line plot shows the cost in dollars for parasailing for different companies on a certain beach. So it says to draw a vertical line through the middle of the data. So that's going to be through here, middle of our data. And then what do you notice? Well, what you might notice is that we have the same information on the left side that we do on the right side. Not numbers, of course, but the same amount of data on both sides. So the same amount of data on both sides. On both sides. Now looking back up, when we were doing our little mismatch, what did that mean whenever we had the same amount of data on both sides? That's same. One of the words shown above was symmetry. So the cost of parasailing are symmetric. Sorry, you're not going to be able to read this, but are symmetric based on the highest and lowest cost. All right, then we've got data that are very evenly distributed between the left and right side have symmetric distribution. The distribution shown over here has a cluster where several of the data values are within the interval 10 to 12. And then they also have some gaps here and here where we don't have any values for 9 and 13. And then the value for 10 is what we call the peak because it is the highest amount of data and because it has the most frequent occurring. So think of it as if we were putting, dots. This is our 8 just has one. This is one value. This is 2. This is 3. Over here, 10 would have 3, and then 11 would have 2, and 12 would have 2, and then 14 would have 1. But what you see is that that's the peak. That's going to be the highest point on our graph because they have the most occurrences. All right. Now, it says describe the shape of each distribution. The line plot shows the temperature in degrees Fahrenheit in a city over several days. And so using the terms that we've learned, we can say that we see that there's a gap between 18 degrees and 22 degrees, meaning that there's no days where we had 19, 20, or 21 degrees Fahrenheit as our temperature. We can also say that our peak was 22 degrees Fahrenheit. And then we can also say that there's clusters between 16 and 18 degrees Fahrenheit and 22 and 25 degrees Fahrenheit. And then we'd also say that there are no outliers. There's nothing that's out there. All right, so the box plot shows the number of visitors the gift shop has in 1 month. And the thing with a box plot is that if we have, like little small whiskers and a really tight box and a little tight whisker again, that would tell us that we have more clustered information. But when we have something like we have in this picture here, where it's all kind of spaced out evenly, we can say that we have symmetric distribution, since we have our median here, and then we have, the same amount of information on each side, the same spacing of information on each side. So we can say that it's evenly distributed, but we can't say if we have, outliers, they would show with a little asterisk. Remember that? So we would know about an outlier, so there is no outlier here, but we don't know about gaps and peaks and clusters because everything is just really evenly spread out, and they don't give us information on which one had the most. All right, for example A, it says use clusters, gaps, peaks, outliers, and symmetry to describe the shape of the distribution to the right. So using those key words, clusters, gaps, peaks, outliers, and symmetry, go ahead and write something down that you think would have anything to do with this. Notice that this is their, this is their kind of explanations that they use. So maybe you can look back at those in examples 1 and 2 to figure out how you want to go about saying it in A here. Pause the video now, please. Alright, so here is the explanation that I wrote. I've got there isn't an outlier, okay, because there's no gap, okay. I actually also would say that I do say there are no gaps down here. I probably could have set it up top there. The peak in our data shows most solar eclipses last between 1 second and 2.5 minutes. And then there are no gaps, there's not symmetry, and then the data is clustered between 1 second all the way to 12.5 minutes. I say clustered because there's not any gaps, so this is where all the information is set up. Alright, so I really like this. It says measures of center and spread, and it's telling you what to use and when. So this is really important. This is something that if you were to have notes for a quiz, this is something really important that you'd want to write down separately. So it's saying that we can use the following flowchart to decide which measures of center and spread are most appropriate to describe a data distribution. Excuse me. So it says, is the data distribution symmetric? If it is, then you're going to use mean, and you're going to use mean absolute deviation to show the spread. And then if it's not symmetric, then you can use median, and you can use the interquartile range to describe the spread. So again, looking at the information, figuring out whether or not you're going to use mean or median, it's going to be based on whether or not you have some crazy outlier, right? Because we're looking for it to be symmetric. We're going to use mean and mean absolute deviation. Whereas we can use median if there is some kind of outlier involved and that there's no symmetry. So for example number 3, it says a line plot shows the number of states visited by students in a class. Choose the appropriate measure to describe the center and spread of your distribution, and then justify your response based on the shape of the distribution. So we're looking to see whether or not this is, going back to our flowchart here, is it symmetric or is it not symmetric? If it's symmetric, we use mean. If it's not symmetric, we use median. And it's not symmetric, so because there is an outlier, first of all, so we are going to use median. Remember that when we were going over the appropriate measures, if there was an outlier, like an extreme value, then we would default to median instead of using mean, because that outlier really affects that mean. All right, so we're using median, and we're going to also find the interquartile range to find the spread. So B says, write a few sentences describing the center and spread of the distribution using the appropriate measurements. And of course, they have their little written thing here saying that the median is 12, the first quartile is 11, the third quartile is 13, the interquartile range is 13 minus 11, which is 2. And so that's for two states is the spread. The data is centered around 12 please. 12 states, and the spread of the data is around the center. Around the center is 2 states. I'm going to show my work that I used originally. It's a lot, so it's wonderful. And so here we go. I showed how I found my median by using my position n plus 1 divided by 2. There were 19 altogether, so my position 10 was my median. So I found that to be under 13, or sorry, under 12. I didn't circle it, sorry. And then 11 was using the n plus 1 again to find the position. This time I know that there's 9 data values before the 10th data value. So I'm going to say 9 plus 1 is 10, divided by 2 is 5. So it's the 5th position from the beginning and the 5th position from the end that we can find our quartiles 1 and 3. So you see that the median is 12, the quartile 1 is 11, quartile 3 is 13. I subtract those to get 2. I showed everything here. Again, median is the way to go because we have an outlier. Anytime we have an extreme amount, we have to use median as long as there's no gaps in the middle. So example B says to choose the appropriate measures to describe the center and spread of the distribution. So justify your response based on the shape of the distribution and then describe the center and the spread. So we are going to figure out, are we going to use mean or median? Why? And then we're going to use whichever that is to figure out either if we go with mean, we need to find the mean absolute deviation. If we're going to go with median, then we have to find the IQR. So decide which one is the appropriate measure and then find the solution. Go ahead and pause the video now. When you come back, I'll have a whole lot of answers. So mean was the appropriate one. I don't know if you guys realize that or not. And so here's all my work. First and foremost, I had to add together all of my values. So to find the mean, we add up all our values, which I wrote out here. Then I figured out the mean average or absolute deviation by finding out the difference between the mean, which was 29, and each of these values individually. So 29 minus 25 was 4, then 3, then 3, then 2, 2, 2. I'm going to show you in another example how you could have combined without having so much extra work. Actually, I'll show you right here. So you could have done 25 plus, and instead of 26 plus 26, you could have said 26 times 2 plus 27 times 3 plus 28 times 4, and so forth and so on. And then you would have had those amounts a little bit faster maybe if you did your multiplication and then added up those bigger numbers instead of adding up all these smaller numbers. When I did that, when I found my deviation then, after I got my 29 from mean, I found out the differences between my values and the 29 divided again by 24, even though I know that there's going to be zeros there. Remember, zeros are part of our data values, so we're going to divide by the same amount, which is 24, and that ends up being 1.67. So in words, the average or the center of the data describes the age of a tennis player is 29 years old, and with a 1.67 years spread between the ages from the center. Now again, you can stop watching if you'd like, but I'm going to start going over some extra examples. I've got example 10 here where it says the box plot shows donations in dollars to charity. So describe the shape of the distribution. Because it's a box plot, we're going to be using those key terms, okay, but there's a lot of things that we can't see because of it. Now, one thing is that, let me put this back up here. Okay, we do know what the outlier is because they always show, they always show it with an asterisk right here. So we already know what the outlier is, the $220. That's the outlier. Then we know that there is a gap between the 160 and the 220. Where there are no donation values under, 160, 180, 200, and 220, or, well, to 200. Then we've got, let me see if we can see anything. I was saying that, and I didn't write this down, but I was thinking that this information is more clustered together, whereas this information is more spread out. Because remember, in a bring in your box tops. In a box plot, the closer your data values are, the more clustered they are, the smaller your whisker and your box will be. The more spread out they are, the larger your box and whisker will be. Okay. Now I'm going to look at number 11. It says the line plot shows the number of miles Alyssa ran each week. It says to choose the appropriate measure to describe the center and spread of the distribution. So we're again going to decide if it's mean or median we want to use. Then we need to justify our response based on the shape. So do A and B. B is also going to ask us to find that center and spread and describe what we find. Okay, so go ahead and pause the video now and try out 11 on your own. So I chose the mean because there's symmetry. Oops, sorry. Because there's symmetry, and that's all I needed to say for that. And then as I figured out what my actual mean and mean absolute deviation was, I found that the center is 31 miles per week with a spread of 1.27 miles per week from the center. Okay, so I added up all my amounts. Here is where I showed where I combined my numbers. I knew that there were 2 28s, 2 29s, 4 30s, and so I multiplied each of my values so that I wouldn't have so many numbers to write down. And then I multiplied them all together, and that's what I did here. And then I added those together and then divided by the 22. All right. So those are 2 examples, just like we showed in the examples in the book. Hopefully this won't delete, and I'll see you in school. Have a great day.